Hi, today we're going to be talking about rational exponents. We've already dealt with negative exponents, positive exponents, and simplifying them, and now we're going to talk about having basically exponents that are fractions. So if we look here, and this is a little bit confusing to understand, but let me show you, I rewrote this. Okay, so if you look right here, right, you understand what this means. 3 to the first power is a 3, 3 squared is 2 threes, 3 cubed is 3 threes. And so we remember the rule of 3 to the 0 is a 1, and today we're going to talk about what happens if you have a fraction there. Well, the way that I can think about it is like this is, I'm adding threes, and then here I'm basically saying what times itself is going to get me that. So, this is like how many threes, and to go backwards, I end up square rooting. All right, so the easiest way that I can think about explaining this, or the trick to it, is if I have a number that's underneath a radical, that is my base. If I had an exponent here, which I do, it's a 1 if you don't see one, then that is the numerator of the fraction, and this is a square root, so that's like a little 2 there, and so that's why it's 3.5. So basically the exponent is the numerator, and that's called the index number, the number that's describing the kind of radical, the square root or the cube root, is the number that's going to be the denominator. Okay? So that's the basic gist of it. It's just like a little robot. You're just, plugging in and going along here. So the base is a 7. The exponent on the 7 is a 1. So when you put it in fraction form, and then this is the cube root, so that becomes the denominator there. Okay, here you go. The base is an m. The exponent is a 1. And the index is a 5. So it's m to the 1/5 power. Right? It's really easy, but it's also easy to get mixed up on that too. Okay, so let's look over here at b. b is the base. 3 is my exponent, and that's my numerator. This is a square root. So if you don't see a number in here, it's a 2, and if it's something else, they'll put it. All right? C, the exponent is 4, so that's your numerator. The index is a 3, and that's your denominator. Here, 2, -4 over 5. All right, so that becomes your numerator, and that becomes your denominator. And that's kind of one part of the lesson, is just going back and forth, writing from square roots into where you have an exponential form, and then going the other way around. Now that I think about it, and I don't really have any questions here going the other way around, so maybe I should make some up. I'm gonna input this right now. If I had, let's do j to the 2/3 power. Well, if I had to write that, I would say that is the square, put my root, I put j on the inside, my exponent is the numerator, and then this guy goes right in here. Okay, let's do another one. If I had, let's say, m to the -1/2 power, I'm going to put an m underneath my radical sign, and that's a -1. So if it was just 1, I wouldn't have to put it, and then 2 goes in there. Okay? All right, so now what we're going to do is we're going to use what we know from the previous lesson to solve for x. All right, so you're probably looking at this going, okay, what do I notice? Well, I notice that it's 3 to a power, 3 to a power, 3 to a power. So that's really nice. I think of before when I had like a squared and a cubed and all these a's with different exponents. What did I do to the exponents? Well, I had to add them. All right, so since these bases are the same, I can just add these exponents, and they should equal this over here. So I'm going to say, okay, x over 2 plus x over 3 is going to equal 9. And I'm trying to solve for x. All right, so I'm going to say, well, I don't want to deal with these fractions. I'm going to multiply the entire thing by 6. So So when I multiply this by 6, I get 3x. When I multiply x over 3 by 6, I get 2x. And I have to multiply the 9 as well because I have to distribute this to everything. That's 54. When I combine my like terms, I have 5x equals 54. Divide both sides by 5. X equals 54 over 5. Not really a nice answer, but not sometimes it is just not a nice answer. Okay, so same gist over here. Because these bases are all the same, I can just go ahead and say that normally what would I do? I would add my exponents and then they would be added over here. So I can just use the same numbers. X over 4 plus x over 6 equals 3. And that works because they all have the same base. Okay, now I'm going to multiply the entire thing by 12. So I'm coming up with this number by looking here and just saying, oh, the common denominator here would be 12. So let me multiply that by 12 and then it should all work out. So when I cross cancel things here, this ends up getting to be a 3x, right? For those people that are confused, I'm basically saying 12x divided by 4 gets me 3x. 12x divided by 6 gets me 2x. And then I have to remember to multiply it over here as well. All right, so now I add my like terms. I have 5x equals 36, so x equals 36 over 5. All right, now if you look at this bottom section, these are no longer, the bases are not the same. So all we have to do is make them the same. So you should say to yourself, well, the smaller base is better. We have a 3 here. So how can I make this base a 3? 3 to what power is 27? So 3 cubed is 27, and I'm raising that to the x minus 4 power. Okay? And so now you can see, well, what do I do when I go power to power? I multiply. So now I have 3 to the 3x minus 12. And this equals 3. This nothing I'm really doing to over on this side. But now that the bases are the same, I can set them equal to each other and solve for x. 3x minus 12 equals 2x minus 6. Subtract 2x from both sides. Add 12 to both sides. And my x equals 6. Okay, this one's a little trickier over here, just because the number is larger and I don't know my 4. Like, I just knew that 3 times 3 is 9 times 3 is 27. So I'm going to probably have to mess around a little bit on here and say, you know, let me try, see what 5. I want this base to be a 4. So 4 to what power gets me 256. And if that won't work, I might have to go down to 2. But let's take a look. Okay, 4, let's try 4 to the, 5th power. Okay, too big. 4 to the 4th power. Perfect. Okay, so this number right here, I got by saying 4 to the 4th power. So I'm just rewriting. I didn't actually do anything yet. And this already has a base of 4, so that's good to go. So now what would I do when I go power to power? I multiply. So this is 4x plus 8. All right, so now my bases are the same. I just have this exponent stuff. I can put them equal to each other. 4x plus 8 equals 3x plus 9. All right, and I just solve normally. Subtract 3x from both sides. Subtract 8 from both sides. So x equals 1. All right, so that's kind of, I know it's a little bit basic today and we're not getting super complicated, but I think that's gonna help you guys out. Have a good day.